Hey guys, Mr. Browning back here to talk to you guys about graphing again. As a prerequisite to this video, you should probably see or watch the video just on basic graphing, and then go ahead and watch this video. So in this video, I'm really just going to show you how you can take a single set of data and actually create three different graphs: a distance time, a velocity time, and an acceleration time graph. Alright, so here's the single set of data. We're going to have the time distance data, and you can pretty much do this any way that you want. You can go from a velocity time graph to a distance time graph, or a velocity time graph to an acceleration time graph. This is just the most simple way to explain it to you guys. So first of all, we can just graph this data 0, 2, and then 2, 6, 6, 12, 20, 30, 42. So it's pretty much going up by 2, then up by 4, then up by 6. And so what you end up with, it almost looks like an exponential line all the way up to about the 6 seconds. Okay, once it gets to that point though, you'll notice that, okay, it goes from 5 to 6, 12, and then 12, and then 12, and then 12. And so rather than having this exponential line, it ends up just being kind of a straight line. That's just going to go like this. Okay? So the red line, let's make sure we make a key here. The red line is going to be our distance. That's our distance line right there. Move that red one down. All right, next. So how do we actually use this data to make a velocity time? Well, first of all, velocity is the change in distance given an amount of time. Okay, so for example, if you wanted to figure out the average velocity, okay, they want a total of 90 meters in 10 seconds. So that's 90 divided by 10. So the average velocity is 9 meters per second. But you want to make a graph that's showing the velocity at each of these points. And so all you have to do is you're looking at the change in distance each second. Okay, so it goes from 0 to 1. There's difference between 0 and 1 is 1 second. 1 and 2, 1 second. Again, 1 second, 1 second. And if you know the calculation for velocity, it's distance divided by time. And if time is always 1, then we can figure that the velocity is simply just the change in the distance. So the velocity here, the difference between 0 and 2, so the velocity here is 2. It went 2 meters in 1 second. And then it went 4. Okay, and then it goes 6. And then it goes 8. And then it goes 10. And then 12. Alright, and then it does 12 again, 12 again, 12 again, 12 again. And so, if we were to do this line, you can see that it would be a linear line, a straight line, all the way up until about 6 seconds. So you have 1, 2, 3, 4, 5, 6. I'm going to make an orange mark here. So it's just going to kind of be a linear line going upward all the way till the 6th second. And then, because the velocity stops changing, it's at 12, it's going to go flat. Okay. So again, we're going to go ahead and label this line velocity. Velocity. Next, let's talk about the acceleration time graph now. Alright, now again, acceleration, unlike velocity, so velocity is the change of distance over time. Acceleration is the change in velocity. So we're just looking at changes in. And so the change in the velocity here is, it goes from 0 to 2 to 4 to 6 to 8 to 10 to 12. Okay? And so you can see that the acceleration, it is changing by 2. we have 2, 2, 2, 2, 2, 2, up, and then 0. And so what this is going to look like, and I'll do a green line here, it's going to be a straight line because it stays at 2 all the way until the 6th second. Now if it drops down to 0, then that means we plot down, it goes straight down and straight across. Okay, so it's very, very easy to take one set of data and create the next two, because you have to remember the velocity is the change of distance, the change in the distance. And then acceleration is the change in the velocity. So if you can get the velocity, you can get the acceleration. Now, if we were to actually look at some data here, and this data comes from the book, this is actually part of the physics talk. It's just showing you a distance time graph, velocity time graph, acceleration time graph. The distance time graph, you can see if something is not moving, you get a straight line. If something is moving at a constant velocity, you get a linear line going upward or downward. And then if you have acceleration, then you get a curved line. And then you can see here, okay, well, velocity time. If something's not moving, velocity is at 0, and obviously acceleration is at 0. Then if you have the linear line for the distance time, the velocity is a flat line, and then the acceleration is at 0. And what we just pretty much drew is, if there is acceleration, you get a distance time graph that has an exponential growth, a velocity time graph that has a linear growth, and then the acceleration is just going to be above or below the 0. Alright, now if you guys have any questions about this and how to go from one set of data to another, make sure you write it down, let me know during class. Other than that, see you guys next time.